Hey everyone, Ari Mahpour here, and today we're going to show you how to get Zephyr OS on the RISC-V processor, the Hazard3, on the Raspberry Pi Pico 2W. I know that's a mouthful, but this is a open source architecture, RISC-V, if you're familiar with it, and it runs on the Pi Pico 2. We're going to set it all up. We're going to get the operating system running, and we're going to show a little kind of blinky LED project. So get your Pi Pico 2 up and running, join me, and let's get started. This example project is running Zephyr OS on the Raspberry Pi Pico 2W, but we're running it on the RISC-V, the Hazard3 core that sits alongside the ARM Cortex on the Raspberry Pi Pico 2W. Now, I also have, for demonstration purposes, I also have an LED hooked up to the pin over here. Its pin GPIO is designated over here. I talk about it, but I hook it up on pin 19, like the physical port pin 19. That's called GP14 for anybody looking at the schematics. I also shamefully did not put a 330 ohm resistor in between. I was in a big rush and couldn't find my resistors. I know, don't follow this practice, please. You should always protect your IOs from your devices from LEDs drawing too much current. In this case, I've done this before. I've played with it. It's been pretty safe. So what I'm going to do is I'm going to walk you through the process of setting everything up, including setting up Zephyr, which we've done in previous tutorials, but we'll just kind of go through the whole thing. And all of this is 100% in the README. You can just go through the README yourself as well. There are some caveats that I wrote towards the end, as you can see down here. First of all, the Wi-Fi is not supported at the time of putting this project together. I even put the date over here. There are some capabilities that are not in Zephyr OS for the RISC-V. Like I mentioned, the Wi-Fi is not there. There is an open issue for a different problem with exposing the CDC, the communication device, over USB. That causes like a hiccup in the device tree bring up process, the enumeration process. And so I had to kind of work around that. Again, that's in the prj.conf and then the manual initialization in main.c. You can go check out the code and take a look at that, but that was a workaround. There is an active issue in GitHub for the Zephyr project to solve this problem. So just wanted to throw that out there as well. And then I've also got a troubleshooting section at the bottom just to talk about, some of the issues that you might run into. Okay, so we're going to go into the project, dive in and get everything up and running next. What we're going to do is bring up the first Zephyr environment. Now, I am running in WSL on Windows, as you can see over here. We're going to build everything locally, but then we're going to talk to the board on the Windows side just because it's a little bit more complicated to use USB IPD through WSL. I want to keep this tutorial pretty simple. So as you walk through the README, you will obviously see that we need to have our board and our LED over here. Don't kill me. I did not put a 330 ohm resistor in there, but I recommend you do that. I was in a big rush and I couldn't find any resistors at the time. So first prerequisite is installing all of the libraries needed for Zephyr OS, or the build environment called West. That I've already done. I've actually already run through this tutorial just to make it fast because the cloning process can take quite some time. I also created a workspace, so I'm going to show you all of that. So let's just skip to this point right now. So all of this is just installing Zephyr and the host tools and everything like that. We're going to create a workspace. So Zephyr project, and I actually made a clean workspace, Zephyr project-Pico 2W. If you already have Zephyr installed or West installed and everything like that, and a Zephyr project space already set up, you can reuse that. I just kind of wanted to keep it clean. First, I'm going to initialize my environment, as you can see over here. and then I'm going to source it. So it should say perfect venv over here. Now I am going to, I've already pip installed this because I've already had this environment set up. So that's there. Then I need to clone this project right over here that we saw, put that over here. Theoretically, you don't have to. I can point and build within over there. Zephyr, I don't know, wants you to like bring their whole SDK and build within their environment. And then it just makes it easier if you just build it there. There are ways that you can build it in your repo, but whatever. I just want to show like an easy way to set this all up. So I've pipped installed this. I've git cloned actually. I'm going to show you that. So the Raspberry Pi Pico, all of this. And then I'm going to west init, but you're going to see that it's going to fail because I've already done this. So I don't need to west init. The next part over here is I'll do a west update. And this will just make sure that I have the latest of all of the tool chains that's needed for this particular project. And then I will do a Zephyr export. So a Zephyr export is going to then grab all of the CMake packages that I can then go build. So now it's been added to the registry. And then I want to go and install all the pip packages. And then finally, we are going to set up the full West SDK over here. So the SDK install. And then at that point, well, we've actually kind of run this already, but okay, it's going to pull this, set everything up. And then at this point, we could theoretically just install this guy over here, which let's see how long this takes. We may want to quit it. And then at this point, we'll have, here, let me open up another Zephyr project, this guy, and then show you, oh, that's a little too much. Let's just show you here. So as you can see over here, we have, I think I can do a tree-d, I believe, tree level. So I will show you just the level 2, let's say. So what is it? Tree 2. Okay, well, whatever. We'll just show you this way. So as you can see, I have the bootloader, the build, the modules, the repo that we talked about, tools, and then Zephyr. So in this repo, we should have, yes. So you see all of the source code and everything like that. So now what we want to do, yeah, this is taking quite some time. I think it might be worth, we don't need to build the whole West SDK. What we really care about is this guy. So let's just do this because we really only need the RISC-V for Zephyr. That's really kind of all we care about. And then we're going to throw our code on top of that. So it's going to install the tools. And then what we're going to do is we're going to build this guy over here. So we're going to build. Okay, so we're going to build for the RP Pico, and we're going to build a clean, right, pristine always. We're going to build for the RP Pico for the Hazard3 specifically. So that's why we needed the Zephyr OS SDK. So let's do this guy. Okay, this is going to take a second to build. And after we've built it, we should get some sort of like printout that's saying, okay, this was the memory amount of memory used and everything looks good and all of this, so which you'll see over here. So if I go into the pretty format of this. Okay, so it'll say like memory region. Here you go, memory region 12.9% used. Okay, now I am going to, so here is the location. So where this location actually is on the WSL side. So I am going to pull up a WSL window. Okay. and then Zephyr project Pico W, and it said it wrote to build. And in build, so this is project Pico W, and we are looking for the ELF file over here. Let's go here. Ari Mahpour Zephyr Pico W, build Zephyr. Excellent. Oh, okay. So actually we want the UF2 file. See, do you see? Converted to UF2. So the ELF, yes, the ELF was the ability to basically flash the device, but you need a UF2 because that's the boot sequence that comes with the bootloader onto the Pi Pico. So let's do this. I'm going to hold the Pi Pico. There is a boot select button over here. I'm going to hold this down while I plug it in, and it'll turn into a flash device like an SD card. And look at that. Okay, perfect. So we want to take this guy here, drop it in. Okay, so you didn't see that because it moved way too fast. So I'm going to do that again. Okay. And then what you're going to see is this LED flash 5 times after I drop this in. Ready? Yes. 2, 3, 4, 5, which is part of the code. Okay, great. And now what just happened is it enumerated as a CDC comm device. Okay, so again, all of this is in the code. It's hard to go through all of it all at once because I wanted to make this as simple as possible. But you can see that in the main loop, we enable the CDC, as you can see, and then we go into the Zephyr, the whole operating system and everything like that. So I'm going to show you everything right now. So serial, this guy, and now I'm going to hit enter. Voila, look at that. Pico 2W on RISC-V with Zephyr RTOS. Type help. Let's type help. LED on. We ready? Aha, voila, LED off. Beautiful. So we can also do a bunch of other commands, things like that. This was a little bit kind of rushed through, but I wanted to just demonstrate in super small bite-sized chunks on how to get this up and running. Definitely check out the code, check out everything in this demo. There's a lot to ingest. This is just the tip of the iceberg. There's so much more you can do. Post your comments, let me know what you think, and definitely see what you can add to the discussion. So today we took the Pi Pico 2W and we put Zephyr OS, but more importantly, we're using the RISC-V side of the processor. So we're not using an ARM processor, we're using the open source RISC-V. And what this did was give us the ability to prototype and play around with a new processor type that a lot of people are not familiar with. If you enjoyed this video, please check out the rest of the videos in this channel. Definitely subscribe and hit that like button. Thanks for watching.